Morning Year 6 and welcome to your first lesson, your first maths lesson of week 5. This is going to be your arithmetic lesson. So as always, I'll have the questions up on the screen and I'll be doing them at the same time. Now I've not looked at any of these questions yet. I'm going to be doing them all with you. So I'll be working them out with you as well. So hopefully you've had a chance to have a go at it. It'll be on your PDF this morning that we uploaded on Class Dojo, and then you can watch this video to see what the answers were. Now I might make some mistakes. That's absolutely fine, you just have to bear with me. Right, we'll start with number 1 then. So number 1 was 168 divided by 8. So with this, I need to know my 8 times table. And I'm going to set it out like a bus stop method. So how many 8s go into 1? None. How many 8s go into 16? 2. How many 8s go into 8? 1. So the answer then would be 21 for question 1. Question 2 then, 97 add 10. I could do that in my head. Just another 10 more than 97, that's 107. Or if I needed to, I could then have set it up like column, and then 7 add 0 is 7, 9 add the 1 then would have been 10, so I would have got 107 that way. Then I've got a nice easy question for question 3, 251 times in by 3, so I just need my 3 times table for this one. 3's into 1 are 3, 3's into 5 are 15, and then 3's into 5. What we're talking about, 3 times 5, and then 3 lots of 2 is 6. Add the 1 is 7. So 753 then for question 3. Question 4, on fire. So just like any sort of subtraction, we're just going to set it out, but making sure that our decimal points are nice and in line. That will then make my answer a lot easier to understand. So 6 tenths take away 4 tenths are 2 tenths, and then 9 take away 0 then is 9. Is that right? Yes, that's right. So then it'll be 9.2 as your answer. Question 5. It doesn't matter which way around they've put the equals, does it really? So we're just knowing that we're adding these two numbers together, and then I'll get the answer here. So column again. We love a good column method, don't we? 7,092 add 582. So this is just testing if I know how to carry on to the next column. So 2 add 2 is 4. 2 lots of 8 is 16, add 1 more is 17. Now take it into the next column. 5 add 0, add 1, then will be 6, and then 7 there. So my answer should be 7,674. Next one then, this is testing if I can rename when it comes to subtracting. So 812 take away 80. There we go. So 2 take away 0, then will be 2. This is the bit it's testing. Do I know how to rename? 1 take away 8 I cannot do, so then I need to rename 100 into 10 tens. That's why now I've got 11 tens and not just 1 10. So 11 take away 8 then should be 3, and then 7 take away nothing is 7. So my answer should be 732. Question number 7 then. So 108 divided by 12. Well, all I need is a 12 times table for this, don't I? What times 12 is 108? Sorry, yes, what times 12 is 108? So I could set it out like this. And then, but what you'd probably end up doing is you'd end up with 108 again. You go 12s into 1, I cannot do. I'll take that over there. 12s into 10, I can't do. So I'm going to put it all the way over there. And look, I've ended up with 108 again. So all I needed there was my 12 times table. So then I know that 9 times 12 is 108. If I know that fact, then I know that 108 divided by 12 would then also be 9. So my answer then should be 9. Question 8. Again, it's just testing the same as question 4. It's just that the only thing it's doing this time is it's not giving you the whole decimal number. You've just got to work out that 1 is the same as 1.00. Why have I put 2 zeros on the end? Well, the answer, the number I'm trying to subtract is 2 decimal places long. So if I make my 1 2 decimal places long as well, I've got no tenths, no hundredths, then I should be very easily, just like I've done here, 0 take away 7 I can't do, 0 take away 6 I can't do, so then I move over here and I rename that 1 as 10 tenths. Now I can borrow one of those 10 tenths as 10 hundredths, so now I can do 10 take away 7 is 3, 9 take away 6 is 3, and then 0 take away 0 is 0. So my answer then is 0.33. Question 9. Oh, easy. So question 9 then here. It's just a case of, I know I'm working in sevenths, so I've got 6 sevenths, add 4 sevenths. I've got the same denominator, so that's fine. I'm literally just adding 6 pieces of that cake, because they're both the same size, and 4 pieces of that cake together. 6 add 4 equals 10. So then I've got 10 sevenths. Bonus point, you manage to then understand that that is the same as 1 whole piece, because 7 sevenths make 1 whole. So then I should end up with 7. I used 7 to make 1 whole, 8, 9, 10. 3 sevenths left over as well. Okay, so a big smiley face if you manage to then change it, convert it into a mixed fraction. Number 10 then, nice and easy, times tables. First of all, I just need to do my 5 times table. 5 times 9 equals 45, and then times that then by 2. So then 45 times by 2. Some of you might be able to do this inside your head. 5 lots of 2. That's right, yeah, 5 lots of 2 are 10. 4 lots of 2 are 8. Add 1 more is 9. So my answer then should be 90. Question number 11. Oh, nice and easy, this one. 93.01. I'm dividing by 10. Now it's dead easy to divide by 10. Remember, that's when we shift everything either 1 space to the left if I'm getting bigger, or 1 space to the right if I'm getting smaller. So if I put my decimal point in place there, I'm dividing. Those of you in my class will understand what I mean by moving to the window. We're going to get smaller. So all my places, because I'm dividing by 10, all my digits are going to move 1 place to the right hand side. So I start off by this 9. Where's that 9 going? That's going to move into my ones column. Where's the 3 going? It's now going to move into my tenths column. That 0 is then going to be my hundredths, and that 1 then is going to be my thousands. So my answer should be 9.301. Number 12. 2 cubed add 4 is that. So what is 2 cubed? And then adding 4. Well, 2 cubed is 2 times 2 times 2. 2 times 2 is 2, times 2 again is 4. So that's 4, add 4, which then equals 8. Next one, 13, 720 divided by 8. Again, I just need to know my 8 times table. Let's put that here. What number are we on? 13, 720 divided by 8. That's right. So how many 8s go into 7? So I would do it just like I would do any other bus stop method. So 8s into 7 I can't do. So 8s into 72 then would be 9, and 8s into 0 then would be 0. So my answer then would be 90. Question 14, another check here whether or not you can rename bigger numbers now. So 5,621, take away 1,421. In fact, I'm not even renaming. That's dead easy to do, this one is, isn't it? Straight away, I know that 21 take away 21 will be 0. And then 6 take away 4 is then 2. 5 take away 1 then is 4. So my answer should be 4,200. Why is that one on number 14? That's too easy. Another easy one for question 15. Sometimes I always think that. I always thought it got easier, it got harder as you went along. But sometimes they throw in some easy ones. I don't know if it's just to throw you off track. 4 11ths take away 3 11ths. Again, just like we've got up here, we've got the same size slices as such with 7ths. We've got 11ths this time. So all I'm doing is taking, I've got 4 of those slices and I'm taking 3 of them away. And Mum said, can you go get me 3 slices of cake, please? How many have I left behind? Well, 4 take away 3 then will be 1 11th. Easy. I don't understand why that's number 15. Number 16 then. Here we go, 1,000 times that number there, 4.56. Well, if I'm timesing by 1,000, it's the same as what we've just done here. Remember, this was dividing by 10, what we're doing here. This time we're timesing by 1,000. So I'm still timesing by a tens number, but it's still the same sort of thing. So this time, again, if you're in my class, you understand what I mean by moving to the door, you're going to get bigger. Your numbers are going to move to the left-hand side. So if I've started off with 4.56, and I'm timesing by 1,000, when I look how many zeros are in 1,000, that gives me the clue of how many times I'm going to move my digits. 3 times I'm going to move my digits to the left-hand side because I'm timesing. So I'll put my decimal point there. This 6 now then is 1, 2, 3 is now in the tens column. That means that this 5 would be 1, 2 in the hundreds column. And that means this 4 is 1, 2, 3 in the thousands column. And then I've got no ones, no tenths, no hundredths. So my answer then should be 4,560. Now you can work that out because what is 4 times 1,000? 4 ones times 1,000 will be 4,000, wouldn't it? So I know that that's going to be my biggest digit there. And then the rest then I can just fill in behind it as well. That's how I would think about it in my head, really. 4 times 1,000 is 4,000, fill the rest in. Done. That's how I would think about it if I was doing my year 6 stats. 17 then. 21.64 times in by 4. So 4 times 4 is 16. 6 times 4 is 24. Add the 1 is 25. Decimal point, decimal point. 1 times 4 is 4. Add the 2 is 6. 2 times 4 is 8. So my answer should be 86.56. Question 18. I reckon I can fit this on here. Oh, nice and easy, that one. 90,000. 1, 2, 3. Add 10,872. So I know that I'm going to need my next column. That's what it's testing you for, isn't it? Because I've got 90,000, 10,000, and it's telling me to add another 10,000. So this is just testing. Do you know to go to the next column? So 0 add 2 is 2. 0 add 7 is 7. 0 add 8 is 8. 0 add 0 is 0. So 9 add 1 is 10. So my answer then is 100,872. Done. Okay. Right, let's flip over. Question 19, 25% of 4,200. Well, I know that 25% is like a quarter of something, isn't it? It's dividing something by 4, because remember, a cent is out of 100. If I did, remember this line that we did, what's in the middle? 50. What's in the middle of that? 25. What's this one then? That'll be 75. So I know then to get 25%, I've divided it into 4 equal pieces. Okay, so it's like doing 4,200 divided by 4. I'm quartering it. How many 4s into 4? 1. How many 4s into 2? Cannot do. How many 4s into 20? 5. How many 4s into 0? 0. So my answer then should be 1,050. Question number 20. Divided by 12 again. Here we go. 8,400. Just like my bus stop method, like I would do normally, need to know my 12 times table this time. So 12s into 8 I cannot do. 0. 12s into 84 or 7. Let me just check. 7 10s are 70. 2 10s are 14. Add them together be 84, wouldn't it? Yeah, so 12s into 84 goes 7. 12s into 0 goes 0. 12s into 0 goes 0. So my answer then is 700. Next one, 21. Oh, same, we've already done one like this before. This is old news now, old news. So it's like 15. The answer I'm taking away is 8.1. So I need another decimal place there, keeping my decimal points all in line. And again, it's just testing, can I rename? So that will then become 4. So 10 take away 1 is 9. 4 take away 8 I cannot do. So 14 then take away 8, 8, 9, 10, 11, 12, 13, 14 is 6. There we go, so 6.9 is my answer. Question 22. We've not actually done anything like hard yet, have we? These are all very just similar to what we've just been doing. So again, another bus stop method. I just need to know my 9 times table. I know my 9 times table because I know my trick from that with my fingers. So I'm dividing by 9, so I need my 9 times table. 9s into 1, can't do. 9s into 16 will be 1, because it'll be 9, 10, 11, 12, 13, 14, 15, remaining 7. 9s into 72. Well, the closest I can get there, sorry, 79. The closest I can get there is 72, which is times in by 8. 8 lots, which is 72, 73, 74, 75, 76, 77, 78, 79, remainder 7. And then the 9s into 72 would then be my 8th finger. So then that would be 8, no remainder. So 188, happy days. 23. Ah, just another one, isn't it? Just very similar, these questions are now. I'm then just taking away, making sure I've got my decimal points all in place. Oh, look, I need to put another place value there, place value holder. So there we go, put my decimal point in place again, taking them away. Can't do that bit, so I'm going to rename. 10s take away 3, 7. 5 take away 9, can't do, so I'm going to rename. 15 take away 9 would be 6. 1 take away 7, can't do, so I'm going to rename. So 11 take away 7 then will be 4, and then 2 take away nothing. So it should have ended up with 24.67. Exactly the same as just taking away without a decimal point, except for you just got to make sure your decimal point is in line, and you get exactly the same answer. 24 then. Let's see if this is a challenge this time. Oh, times in fractions. So remember, we like times in fractions because it's exactly what we want to do. Times the top numbers, times the bottom numbers. 1 times 1 is 1. 4 times 5 is 20. There you go, 1/20th, done. So we like times in. That's the easiest way. That's the easiest thing to do with fractions, isn't it? Here we go. Now we're talking. Now we're getting into some big juicy stuff. 25. So that's 35 times. I'm going to think of it as times 6 to start with. I can do that. 5 times 6 is 30. Yep, there you go. And then 3 times 6 is 18, 19, 20, 21. Ta-da! But actually, now I'm timesing by 30 here. I'm timesing by 10's number. I can put the 0 on the end. And now I just pretend I'm timesing by 3. So 3 times 5 is 15. 3 times 3 is 9. Add the 1 is 10. Ta-da! And then I just need to add those two numbers together. And I've times by 30 and 6, 36. 1 add 5 is 6. 2 add 0 is 2. 1 add nothing is 1. So 1,260. Like the hardest one so far, and it wasn't exactly hard, was it? 26 then now. Making sure I've got everything in line for my column. They've even given you squares to do it. I'm doing it on line paper, but they've given you squares to do it, so you should be able to nail this. And then if I work backwards, 0, 9, 4, 2, 1. Everything's then in line. What is it testing? Probably that I know how to rename. Yes, because I've renamed already. Old news, 4 take away 0 is 4. Rename this one. That then becomes a 7. 12 take away 9, 9, 10, 11, 12 is 3. 4, 5, 6, 7 is another 3. Can't do, so I need to rename. There we go. So 10 take away 2 is 8. 9 take away 1 is 8. 3 take away nothing is 3. So my answer then should be 388,334. 26. Was that 2 marks? No, that was 1 mark. No. I was going to say that's too easy for 2 marks, isn't it? 27, 13. Now this actually, I'm going to do that down here. This one is getting juicy now. Now we're getting there. So 13 times 2 and a half. Okay, so let's think of the wholes first. What's 13 times 2? So 13 times 2 is 26, isn't it? So that equals 26. 30 times 2 is 26. Now what's 13 times a half? Okay, well remember, timesing by a half is the same as dividing by 2. Or I do, to work it out, 13 is the same as 13 over 1, 13 wholes. Okay, and I'm timesing by a half. And we like timesing because we've done it over here. Times the top numbers, times the bottom numbers. Okay, so 13 times 1 is 13. 1 times 2 is 2. So now I've got 13 halves. Well, if I've got 13 halves, I must then have more than 1. So let's work out how many I've got. How many times can I get 13 into 2? 12 times. I've got 12 wholes and a half. Is that right? No, it'd be 12, isn't it? So 6. So I've got 6 wholes. 6 wholes and a half. 6 times a half will be 12. Add the 1 more is 13. So 6 wholes and a half. So then add those two numbers together now. So 26 add 6 is 32 and a half as well. So that's what we've ended up with, 32 and a half. Go over that again. I did 13 times 2, which is 26. Done that now. That's there ready to stay. And then I did 13 times a half. I put 13 over 1, 13 wholes, times it by a half. I know how to time fractions. 13 times 1 is 13. 1 times 2 is 2. And then I simplified that improper fraction into 6 and a half and added those two together. And then that's what my answer would have been, 32 and a half. How many marks did you get for that? Still 1 marker though, still 1 marker. Right, 28. Let's see if we can do this one. So now it's getting a bit harder, just a tad harder though. So 7/10 add 2/5. My denominator is different, so I can't add them together. So I need to find a common denominator. Well, if I times 5 by 2, that would then end up with tenths at the bottom. And then I'm timesing this one by 1, because then it would be tenths at the bottom. So 7 times 1, can you see that? Sorry. 7 times 1 is 7. And then 2 times 2 is 4. So then I'm adding those together there. 7, 8, 9, 10, 11. That's 11 tenths. Then as a mixed number, that's 1 whole and 1 tenth. Ta-da! And then question 29, what have we got there? A few more. So question 29. I need my 16 times table for this. Let's move over, new page. So I write out my 16 times table to start with. This is question 29. So it'd be 16. 6 add 6 is 12. 1 add 1 is 2. The 3 is 2. So add another 16 on there. So 6, 7, 8. Add 1 is 4. 48. Add another 16 on there. So it's 8, 9, 10, 11, 12, 13, 14. Add the 1. 4. Add the 1 be 5. Add the 1 there be 6. 4. One more probably. 6 add the 4 then will be 10. 6 add 1 more be 7. Add 1 more is 80. I reckon that would do. That's my 16 times table. If I need any more, I'll just add them. So then 16 there, 34, 24. There we go. So 16 into 3 can't do. 16 into 34 would be 2 lots with 2 remaining. 16 into 22 would be 1 lot. 16, 17, 18, 19, 20, 21, 22 with 6 remaining. And then 16 into 64 would be 1, 2, 3, 4. So that would be my answer, 214. That was 2 marks, that was. Jeez, that's 2 marks. This is question number 30. So 3 quarters divided by 3 wholes. Now remember, when it comes to divided, we keep it. So 3 quarters. We change that to times, and we flip this. Now remember, 3 wholes is the same as 3 over 1. 3 1-wholes. Okay, so if I flip that, it'll be 1/3. Because remember, dividing by 3 is the same as timesing by 1/3. So 3 times 1 is 3. 4 times 3 is 12. Can I simplify that at all? Yes, I can. I can divide both by 3. So that would be 1 and quarter. So 1/4 altogether. So that would be my answer there, 1/4. Question 31. I haven't got many more to go, I don't think now. 31, 32, 33, 34, 35, 36. Yeah. All right, question 31. Another 1 marker. 19, take away 3 times 4. Just got to remember bod maths. So, or D maths. So I'm doing this bit first. So that is 12. So 19 take away 12 then equals 12, 13, 14, 15, 16, 17, 18, 19, 7. Ta-da, done. Question 32. Oh, again, so it's just a bigger number this time. 1, 6, 4, 3 times by 9 to start with. So 3 times 9 is 20, what is it, 27. 4 times 9 is 36, 37, 38. 6 times 9 is, oh, what is 6 times 9? I can do that, can't I? Put my 6th finger down, it's 54, 55, 56, 57. And then 1 times 9 is 9. Add the 5, then would be 14. Okay, so I've times by 9, now I'm timesing by 80. Okay, because I'm times by 10's number, I put my 0 on the end already. Now I just times by 8. 3 times 8 then is 24. 4 times 8 is 32, 33, 34. 6 times 8 is, well, 7 times 8 is 42. Add 6 more, be 48, 49, 50, 51. And then 1 times 8 is 8. Add the 5 then is 13. Some big numbers here that we've got going off. So then I'm going to add those 2 numbers together. That'll be 7. 8 add 4 then will be 12. 7 add 4, 7, 8, 9, 10, 11. Add the 1 more then will be 12. 4 add the 1 is 6. 3 add the 1 is 4. Add the 1 there. So there we go. So we're 146,227 altogether. Oof, that's definitely worth 2 marks, that one is. Question 33. There we go. So I've got 95% of 408. So quite a few ways of working this out here. Now, the way I would do it is if I found 5%, I'd just take it off 480, and then I found 95%. I've taken 5% away from the 100%, 480 of a 9. So how do I find 5%? Well, can I find 10% first? So if I find 10%, dividing by 10, aren't I? So 48 divided by 10, sorry, 480 divided by 10 is 48. I move all my digits one place to the right. Then to find 5%, Well, I've halved 10 to get to 5. So if I halve this, it equals 24. So now if I take 5% away from 480, I've then got 95%. So 480 is a 100% number. I'm taking away the 5%, I'm taking away the 24, and then I should end up with 456. And that should then give me 95% of it. Okay, question 34. Oof, this should be a 2-marker surely. Yeah, 2 markers here. So I need to have my 78 times table here, don't I? So I've got 78 divided by 3,510. So write out my 78 times table. So 78, so I'm just adding, remember, 8 onto the digits. 8 add 8 is 16. And 7 onto the tens. 7 add 7 is 14, add the 1 is 156. Then do the same again. Add 8 onto my digits. So 6 add 8 is 12, 13, 14. And then 7 onto 15 here would be 22, add the 1 in is 23. And then I reckon one more. Do one more. So 8 add 4 is 12. And then 7 onto 23 would be 30, add 1 more would be 31. Probably one more. Let's do one more. We're on a good roll here. 8 add to 2 is 10. And then 7 add to 31 is 38. Add 1 more is 39. Ta-da! There we go. So that's my 78 times table to 5. 78 into 3 cannot do. 78 into 35 cannot do. 78 into 351 would be 1, 2, 3, 4. I've used 312 of them. 351, take away 312. Like that. So would be 2, would be 9. 4 take away the 1 is 3. 3 take away, so it's remainder 39. That's good. 390. Then it's 1, 2, 3, 4, 5. Ta-da! So I've times it by 45. So that's it. So that's my answer there. And then final, that's a good 2-marker, that one, isn't it? Final 2 questions, both 1 markers. They should be quite easy. The first one is 5/8 divided by 4. Keep it. 5/8. Change it. Flip it. 5 times 1 is 5. 8 times 4 is 32. And 5 is a prime number, so that's as easy as it's going to get for me. And then finally, the last one here. So 2 wholes and a half. Take away 3/5. So that's the same as having 5 halves, isn't it? So that equals 5 halves. Right, take away 3/5. Got to find the common denominator. So if I times that by 5, then I should end up with 10. And if I times this by 2, I should end up with 10. So 5 times 5 is 25. 3 times 2 is 6. So 25, then take away 6 would be 19 tenths. That equals 1 whole and 9 tenths. There you go. So give yourself a mark out of, I think it's at 40 because there's a few 2 markers in there, wasn't there? So give yourself a mark out of however many it is. Upload your working out for me onto Class Dojo, and we should give you a well done on a few dojos for doing it. And I shall see you tomorrow, Year 6. Bye.